All right. All right. Well, good morning, everyone. We'll kick off this first session of the BIM track here. Glad to have you. Maybe a few more folks will trickle in after they get their cup of coffee and muffin. But my name's Morgan Kessler, and I'll be your moderator today. A bit about me, I hail from the Federal Highway Administration. I'm over at the Turner Fairbank Highway Research Center that Craig gave a great presentation about this morning. I'm a research engineer, and I'd say I put about 30 or 40% of my research time into kind of this bigger BIM for infrastructure topic and digital twins. Title of the session today is Go Digital for Enhanced Project Delivery. And I'm excited to have what I thought was two, but three, rock star presenters today from the, big world of expanding BIM for infrastructure. Personally, when I think about enhancing project delivery, one of the things my mind goes to is this idea of leveraging the concept of digitalization, right? Not digital. Yeah. Essentially, in my mind, it's replacing a lot of these paper and manual processes we've had, over the decades with, employing the benefits of digital data, and especially in the context of digital models, which we'll kind of talk about today. Our presentations this morning will go over things like how digital data and processes enable collaborative workflows for managing schedules, conveying design intent, and avoiding construction problems, which we all like. So I don't think we're real crunched for time today. We're supposed to have 3 full presentations. We only have 2 today. So, I was originally going to say, the way it'll work is we'll let each speaker do their talk and hold our questions, for the last 10 minutes. But with this crowd today and 2 presentations, I think it'll be a little more spontaneous than that. So, if you guys are okay with it, folks could just ask questions as they come up. With that, let's get right into introducing our first presentation. We have 2 folks today from the University of Texas at Austin Center for Transportation Research. We have Juan Loayza and Cameron Schmeits. And I'm sorry, I don't have Cameron's bio, but I do have Juan's, and I'll read it. Juan is a civil engineer from Peru, working now in Texas. He graduated from University of Texas in Construction Engineering and Project Management Master's Program in 2020. He's interested in BIM applications for management, construction, coordination, and the use of gaming engines for interaction development. He's been working as a research fellow at the University of Texas at Austin since 2021, giving support with BIM models for Texas Department of Transportation projects located in the Fort Worth area, and including the I-35 expansion project. And when Juan isn't busy modeling TxDOT projects, he enjoys oil painting, playing drums, and traditional Peruvian percussion. So with that, let's welcome Cameron and Juan.
So my name is Juan Loayza. I present the 4D interaction that we as a Center for Transportation Research from UT Austin did for the Texas Department of Transportation. This model includes 2 different road projects, the SH-170 road and MT3C road, which is an I-35 expansion. We will show road and bridge construction interactions on the meeting part of both projects. So Cameron will talk a little bit more about these 2 projects.
So the two projects that we have, you can see the map there in green is the I-35W, it's the Segment 3C expansion. It's a $950 million public-private partnership, so it will include managed toll lanes in the middle, and then we also have some direct connectors that connect into the SH-170 project shown in blue. And so the SH-170 project is a $100 million traditional design bid build project. So both are textile projects, just delivered differently, and we have this interaction. And so because of the need for our managed lanes, to be delivered on time and have connection points from SH-170 to NT3C, there was, some heartburn, some concern from our public-private partnership TxDOT team about making sure that SH-170's project was going to be open and have the availability for those managed lanes to come onto and use the SH-170 facility. They're going to be done pretty close to it, but we've got separate contractors. There's just a lot of interface and interaction that happens both physically and then also contractually, and so we really just don't want to have an impact on the toll lanes. And so, that's where the 4D visualization came in. Is we created our 3D visualization, and the 4D was really to look at are we going to have things coming in, being ready on time, and the projects are still ongoing. It looks like the main portion of the SH-170 main lanes that we need are going to be done. But as we get closer, looking at maybe some temporary, connections, or are they going to want to open first? Are we going to want to open first? And just how all that works. We think there's going to be, some continued use of these 4D models for the kind of, somewhat micro simulation as we get closer to these projects being done next fall. I think I just kind of covered all of that. So now I'm going to hand over to Juan. Juan did all of the beautiful modeling work on all this, and he's going to talk about how he did all that, and he did a great job.
Okay, so there's some project challenges. Project connection has different delivery schedules and different dates, so there are challenges over there. There's a necessity of a connection between them because of the design, and also because the NT3C part, that's the part that belongs to the I-35, it's a toll road, so they need to start working on that in order to put it in function. There are not too many detour paths available, so once the roads are connected, they should be able to be active without interruption. The revenue for the NT3C project depends on the SH-170 opening. The modeling objectives are 3. It's because we're a research department, so it's not only like model for these guys there in the TxDOT, but also it's to increase our capabilities in order to have like tools to handle future projects. So our modeling objectives were the visualization of the connection of the corridors in a time-lapse sequence, the presentation of a detailed bridge construction sequence, and inclusion of realistic textures and surroundings. So for the 3D models, we obtain geometry from DGN files, and we added realistic textures for both projects. And for the schedules, we obtained the several schedule updates from physics that were given by the project team. Now the modeling process, first we obtain a 3D model, getting horizontal, vertical, and cross sections from the design team, and then we added the texture in the 3ds Max. Then we proceed with the so-called resource generation. That's a way to organize the 3D objects that are imported in order to generate groups that will be assigned to different tasks in the next step. So the schedule import, we imported from P6, and we set the scenarios because we obtained 2 different schedules that belong to 2 different updates. And we perform the task assignment, that match between the 3D objects that belong to the resource and the actual activities. And then for the 4D modeling, we perform a little bit of animation in just a piece of equipment and some parts of the project, like objects, beams, slabs, in order to show a construction sequence. I'm going to show a video about that next. And finally, we proceed to render animations, and there are many ways to render the animations. Depends on what's needed. If we need like a general view, if we need like detailed view from project, or if we need a different schedule comparison between the updates. So this is the first animation we obtained. That's a variable speed interaction that allows us to watch the construction sequence. It includes a detailed bridge construction sequence. We use different speed animations in order to show detailed activities such as beam placement, retaining walls, bridge construction, and also road construction. All those components have detailed textures and added surroundings. So we were able to add some filling material behind the retaining walls, and also we were able to animate cranes and show a little bit of like a detailed construction in the middle of a big like project construction or interaction. So we were able to switch between cameras, but trying to show like the pieces that are being in construction in screen. Now we are going to notice a difference between this animation and the next one that I'm going to show now. So yeah, well, you can see that after the bridge is finished, then the road construction continues, and you can spot like several layers, like the construction sequence for both connectors. NT3C is in the bottom, and the SH170 parts in the top. Now it's pavement layers, and finally the concrete pouring for the pavement. So that's the final frame for this model. And this is just a general 4D model that shows the sequence, and we included temporary roadblocks and safety components in order to add a more like context to the animation. Now this is the second interaction we exported, rendered. This is a dual view interaction. In this video, we can monitor different views of the same project. So we can follow SH170 activities at the right side of the screen and NT3C activities at the left side. So both are running the same schedule. So road projects can have like a long footprint. So if you sometimes you use a single camera, then you can spot what's going on at the other side of the project. So you can have this kind of multi-camera, multi-view running the schedule at the same time. And this was exported from Synchro 4D at the same time. We didn't add different cameras like in the video editor or like in a different program. It's just a direct render. Yeah. As to recap, animations can focus in different parts of the project and run the schedule at the same time. You can get detailed visuals for specific parts of the project. Sometimes there's the road, the big road, but there are certain pieces of infrastructure in the middle that you can put some kind of tension and like watch them being built at the same time. And then finally, the third animation, that's schedule update comparison. So we are running two schedules at the same time in the program in order to be able to spot delayed activities and when do they start. The important thing about this is that we can spot changes between the schedules visually. So we can notice that the left side, like bridges, it's been built, but next update, those activities are delayed. We can spot too that the construction sequence, there are changes in the construction sequence, especially in the road construction sequence. So that could be a spot visually too, instead of trying to read a complex schedule. Sometimes you can spot that visually. That makes it like easier for the management team. Or sometimes you have like too many activities, like more than 1,000 activities, and then you can run a program in order to spot which changes have been done to the schedule, like in the next update. But because there are too many activities, then it's hard to know if that will impact the construction sequence in a certain way. So this could be a help to the team, to the project management team, to spot those activities. So this just is a recap. But the important part is that users can spot earlier started and delayed activities visually, trying to be a visual help while comparing schedules. So this is just small feature compilation. You can get construction sequence, multi-view, schedule updates, a variable timeline. Sometimes there are like long activities, and they're like really short activities, like the bridge construction takes just near a month, but the whole project is more than a year. So you can change and alter the timeline scale for certain parts that you're interested or that you want to see. Then we can add camera movements and 3D object animations like the cranes and fail and objects that grow or like disappear between the activities. Also, there are modeling features like temporary signs. You can add like temporary facilities or like parts of the job site that then are going to disappear after the project is ended. Then you can add equipment, materials, excavation fill, and add realistic textures. Well, these are some potential setbacks we identified while using this 4D modeling process. And the first one I think is one, or maybe it's the most important, is that you need the 3D model ready. So sometimes you can get more objects or more 3D objects that you need in order to make the 4D model. So you have to clean it, you have to simplify some parts, you have to cut some objects before they are going to be exported, trying to preserve textures sometimes. And this is one of the most important parts, like to have clean, ready. And also, I put here like the manual resource assignment. So once you get the 3D objects and the schedule, then you have to make the match. Synchro, that's the program we are using, could turn this activity a little bit tedious because you have to manually link each task with the proper resources. Now, if we can if we want to do this in a faster way, we can try to assign some certain coding or some certain kind of number or some kind of naming convention to our 3D objects and then export them to an Excel chart and do that link through an Excel chart and then import in Synchro, and that will be like an automated process and will save us like a big time. And we can like obtain this task assignment match in maybe a couple of days instead of spending like maybe a week if you have like too many 3D objects. Also, we have to consider texture edition compatibility because we imported objects from 3ds Max and we used a certain renderer, but then in order to use those objects in Synchro, they were using another kind of materials, so we had like some kind of clashes between them. So you have to be like sure which kind of materials you're using in 3ds Max before the export. And then other potential setback could be the task and level of the element definition, because not all the activities that are in the schedules are going to be modeled, and not all the 3D objects are going to be modeled. So you have to start simplifying some activities or maybe discarding some 3D objects in order to make them look in the proper sequence, or like not trying to over animate activities that will not show they're not relevant for the animation. And finally, the WBS schedule uniformity. Since we were animating two projects, the two projects had two different schedules, but they were generated by two different companies. So they were using different standards for the WBS. And once we tried to generate the animation for the roads, we had different tasks for the same activity. So we had to agree in some parts and then discard other tasks in order to make them look uniform. This could be avoided sometimes if you implement a WBS standard that will consider a 4D model in the future, or like if it's going to be needed in the project. So you're thinking about activities that could be modeled instead of adding too much detail. So that's a part that could be implemented. And finally, there are future possibilities we are working on. As a team, we have plans to start using the 4D interactions to display the project TCPs, that are the traffic control plans. So we can spot opening, closure, and detour of the different road lanes along the project. So we can like temporary ramps. We can then show lane reduction, and then when a road, like final road, is going to be ready, then we can remove temporary objects, and then remove the temporary roads and do that kind of interaction. That's our that's where coordinating with TechStat right now, because they want to see what's going to happen in other crossroads that they have. And our second plan is to move the 4D models into Lumen RT and get a VR interaction with the 4D model using a headset and watching the construction in real scale. So these two are the two applications of 4D that we're planning to perform in the future. And that's it. Thank you.